Hi everybody! In this video, we're going to be going through the notes for lesson 1.2, which is about visual patterns. So in this video, we're going to be talking about turning visual patterns into tables and graphs that represent those patterns. Let's start with what a visual pattern is. A visual pattern is a pattern made of pictures. When we're trying to understand a visual pattern, it usually helps to count how much total stuff is in each picture. Now, a lot of times we organize that information into a table or a graph to better help us understand those patterns. So let's start with a table. The table is going to have two sides, a left side, which is going to be the input side, and the right side, which is going to be the output side. At the top of those sides, those columns, you need to make sure that you include a label. The label is super important and is required. Now, when we're trying to figure out what information goes in the input side of a table, we want to look at how often the pattern changes. For example, it might be a pattern that is changing every minute, it might be a pattern that is changing in each figure, or it might be a pattern that's changing every hour. But how often the pattern changes is what we put on the input side. The output side, we have to look at what we are counting. Are we counting the number of boxes or dots or flowers in the pattern? This part of the table here is going to be for numbers. The label will be at the top and the numbers will be at the bottom. Sorry, underneath the label. Now, once we've organized information into a table, then it's helpful to make a graph so that we can visualize how the pattern is changing. Now, just like a table has a label and it has numbers for both the inputs and the outputs, a graph has the same thing. So the input label corresponds to the label that goes on the x-axis of your graph. So the first column goes at the bottom of the graph. And the input numbers are the numbers that are on that x-axis. The output label goes on the left side, and it corresponds with the output numbers. So the right side of the graph, the right side of the table goes on the side of the graph. The other thing we're going to need to do is we're going to need to use some vocabulary to describe our patterns. The first set of words you need to know are the words increasing and decreasing. Now, a pattern can either be increasing or decreasing. It's one or the other. So let's start with increasing. An increasing pattern is what we have when the amount of stuff in the pattern gets bigger. We're adding or multiplying more and more and more each time. Whenever you have an increasing pattern, your operations, if I said how much is this changing by, are always going to be addition or multiplication. Those are going to be operations that make our numbers get bigger. And when we look at a graph of an increasing pattern is going to be going uphill when you go from left to right. So out of these four options, this option right here is an increasing graph. And this option right here is an increasing graph. So there's two, this one and this one. The other graphs are actually decreasing graphs. They're going downhill, so those are not increasing patterns. Now, the opposite of increasing would be decreasing. A decreasing pattern is a pattern where the amount of stuff that we're looking at is getting smaller. So just like addition and multiplication make our numbers or our amount of stuff get bigger, subtraction or division make our numbers or our stuff get smaller. Now these graphs are going to be going downhill from left to right. So this time, this graph and this graph, one is a straight line and one is a curve, but they're both going downhill. And these other two graphs are not decreasing, or sorry, not in decreasing, they're actually increasing. In addition to knowing the difference between increasing and decreasing, you're also going to need to know the difference between linear and exponential. Some of the graphs we're going to look at are going to be straight lines, and some of them are going to be curves. So let's start with linear. A linear graph is the type of graph that we get when the pattern was either adding or subtracting pattern. It might be increasing or it might be decreasing, but the graph is going to look like a straight line. So both of these graphs that look like straight lines are linear patterns. It doesn't matter whether it's going up or down. It could be adding or subtracting, but it's going to be linear because it looks like a line. And one of the best ways to remember that is that the word line is actually inside of the word linear. It starts with the word line. Our exponential graphs are going to be when we have graphs that end up looking like a curve. Exponential graphs are going to end up being what we call airplane graphs. They look like an airplane that's either taking off or an airplane that's landing. They're curving, not being straight lines. This is the type of graph that we get whenever our pattern is a multiplying or a dividing pattern. And again, it could be an uphill one or a downhill one. That part doesn't matter. Linear just means line and exponential means airplane. Let's try a couple example problems. So what's going to happen is I'm going to give you a visual pattern and you're going to do three things. Make a table, make a graph, and then use some vocabulary. Let's start with the table. Remember, the input of the table is always going to be how often the pattern is changing. So in this example, we have at the beginning, we have 1 minute, and we have 2 minutes. Now, you might hear the fight song playing in the background. I apologize. That means that the label at the top here is going to be minutes because the pattern is changing every minute. At the beginning really means 0 minutes, and then there's 1 minute, and then there's 2 minutes. So I'm going to fill in 0, 1, and 2. Now, I'm noticing the numbers of minutes are going up by 1 each time here. So the next number would be 3 and then 4. The outputs are going to be the number of things that we're counting. Since this is a pattern that is made of dots in an arrangement, our outputs are going to be dots. There is 1 dot in this picture, 5 dots in this picture, and 9 dots in this picture. So 1, 5, 9. Now, if I look at this pattern, it looks like I'm adding 4 each time. So to continue here, I would add 4 again, and that's going to be 13, and add 4 again, and that's going to be 17. Once I have my table, I'm now going to make a labeled graph. So the input labels always go on the x-axis, which is down here. So my input label is going to be minutes, and my output label always goes on the y-axis, which is going to be right here. So my output label is going to be dots. Now I'm going to graph my points. So when there were 0 minutes, which is right here, there was 1 dot. When there was 1 minute, there was 5 dots. 2 minutes, there's 9. 3 minutes, there's 13. 4 minutes, there's 17. And then I'm just going to connect those dots to make a graph. Now, when I'm looking at this picture and when I'm thinking about this pattern, I can tell that this is going to be an increasing pattern. And the reason that this pattern is increasing is there's actually 2 of them. The first reason is because we had an adding pattern. And addition makes our numbers get bigger, which means it's increasing. The other reason I know that this is an increasing pattern is because the graph is going uphill. It's an uphill graph from left to right, so it's an increasing pattern. Then I need to think about whether this is a linear or an exponential pattern. In this case, it's going to be a linear pattern. And the reason that it's linear is because the graph is a straight line and the pattern is an adding pattern. Adding and subtracting gives us linear, and multiplying and dividing gives us exponential. So I would write, the two reasons here are that there's an adding pattern and there's a line graph. Remember, exponential patterns look like airplane graphs. The word linear actually has the word line built in. Let's try one more example. So in this picture, again, my input labels are going to be how often the picture is changing. In this case, it looks like we have figures. Figure 1, which just means picture number 1, picture number 2, and picture number 3. So this is going to be figure as my input label. 1, 2, 3, 4. And if I continue the pattern of counting by 1, the next one would be 5. And it looks like in these pictures, there's tiny little boxes. So I'm going to count how many tiny little boxes there are. In this first picture, and it's going to take a little while to count them, there's 3 in each triangle of boxes, and then there's 12 of those. So there's 36 here, there's 36 here, which makes 72 total in this picture. That's a lot of little boxes. The next picture, it looks like only has one of those sets. So there's 36 of them. Then there's 3, 6, 9, 12 of them. And then there's 6 of them. It looks like the pattern here is we have half as much each time. So the pattern is a division pattern. We're dividing by 2, which means if I divide by 2 again, my next pattern number would be 3. Now I'm going to make my graph. Now remember, a graph has to have labels as well. So let's put the labels here. The figure goes on the bottom because that's the input label. And boxes goes on the side because that's the output label. Then we're going to make our graph. So 1 corresponds to 72, which is not on this graph paper. I'm just going to go ahead and skip that one. 2 corresponds to... Oh my God, I counted wrong. There's 8 of these. Oh my gosh, you guys. This is my bad. Let's go back. There are 48 of these. Oh my gosh, which means there are 24 of these. What am I doing? So we've got 48 of these. We've got 24 of these. My bad. Sorry. All right, well, now that we fixed that, 1 goes with 48. 2 goes with 24. 3 goes with 12. 4 goes with 6, which is actually in between the 4 and the 8, and 5 goes with 3, which is a little bit underneath the 4. Sometimes you're going to get these weird in-between numbers. Just do your best to estimate where it goes. I can already tell this isn't going to be a graph that looks like a straight line, so I'm just going to come in here and I'm going to land the plane. So it's going to get closer to the ground but not touch. Now I'm going to ask myself, is this an increasing or a decreasing graph? The answer is that it's decreasing, and there's 2 reasons that I know. The first reason is that there is a dividing pattern. The second reason is that there's a downhill graph. Then I'm going to ask myself, is this a linear or an exponential pattern? And the answer is it's exponential. Remember, linear patterns look like lines. There are, again, 2 ways that I know. The first way is that I'm dividing, and anytime you're dividing or multiplying, it's always going to give you this curved graph, and it's going to be exponential. Or another way is that there is an airplane graph. All right, that is it for today's video. Thank you all so much for watching and taking excellent notes, and please open your packets and start your practice.